Welcome to our presentation. Today our group is going to present power management in operating system. These topics explain how computer and mobile device saves energy and increase performance. Our presentation is guided by Mrs. Dishti Shah and we are grateful for her guidance. Before I begin, let me introduce myself. My name is M. Asif Ahmed, my student ID 1064. Our another team member is Rahina Chaudhuri Prithi, Sabi Islam Shifa and Mahdi Asar. What is power management? Power management means controlling how a device uses electricity. The operating system reduces unnecessary power use by controlling parts such as the CPU, scan memory, and background apps. The main goal is to use the last amount of power while keeping the device fast and responsive. Why power management is important? Power management is important because it extends battery life for laptops and smartphones. It reduces heat keeping and system color. It improves performance as the system run more efficiency. It protects hardware, helping the device last longer. It is environment friendly because it reduces energy consumption. Now, let's talk about the components involved in power management. Hardware. CPU works frequency and voltage control. GPU works graphics power regulation. RAM used refresh rate and ideal management. Storage used spin down low power state. And display used brightness and refresh rate. And software are used to as power manager, device drivers, and control modules. Now, our another team member, Raina Chaudhuri, will discuss the next point.
Assalamu alaikum. This is Raina Chaudhary Prithi. My ID is 1076. Let me give you a quick snapshot of the key power states in a computer. Sleep keeps your current session in RAM, uses very low power and wakes up almost instantly. Hibernate saves everything to the disk, consumes almost no power but takes a bit longer to resume. Shutdown turns the system completely off with no session saved. And hybrid system combines both. It keeps your session RAM and backs it up to disk. CPU power management techniques. Here are some CPU power management techniques. Uh, Number one, DVFS, dynamic voltage and frequency scaling. CPU throttling, reduce clock speed. Turbo boost, temporary performance increase. Core parking, turn off unused CPU cores. OS scheduling for power saving. Reduce background processes, delay low priority tasks, it pauses unused services, batch processing for efficiency. Display power management. Auto brightness reduces brightness based on lighting. Screen timeout turns the display off when idle. Dark mode saves power on OLED screens, and adaptive refresh rate shifts between 120 Hz, 60 Hz, or 30 Hz to use only the needed refresh level. This is all about my topic. Next, my another team member, Sabia Islam, will continue the next part.
Assalamu alaikum. I am Sabia Islam Shifa. My ID initial is 1373. Before diving into desktop or embedded system, let me start with something we all use every day, mobile operating system. Let's see how Android or iOS device save power in smart way. Starting with Android. Android use several power saving technique. First of all, we use DOS mode. When the phone stay idle, then Android reduce background activity to save battery. And app standby bucket. Apps are grouped based on how often we use them, and less used app get limited background access. Background activity limits. It use app that run unnecessarily in the background are restricted automatically. Now moving to the iOS. iOS also focus heavily on battery efficiency. First of all, it use low power mode, app nap, and intelligent background scheduling. So both Android and iOS aim to extend battery life through smart background control. Next slide. Power management in Windows, Linux, and Mac OS. Now let's shift from mobile system to desktop operating system, which also have strong power saving feature. Windows. It offers power plan balance, power saver, and high performance. and it also uses modern standby. It keeps laptop updated while using very low power. Linux. We use two tools. TLP tools. It helps manage CPU disk and USB power, and CPU frequency governor. Dynamically adjust CPU frequency to reduce power use. Mac OS. It uses AppNap. It reduces power use for inactive apps, and it also uses energy saver. It includes display sleep and system sleep option. Next slide. Finally, let's move to embedded system which require the highest level of power optimization. Common in IoT device, wearable and sensor. These devices run on tiny batteries or extremely low power operation is essential. They use sleep awake cycle to stay asleep most of the time. Duty cycle and less device activated briefly and then return to low power mode. This is all about my part. My next team member discuss the another part.
Assalamu alaikum. I'm Mahdi Hassan. The last four digit of my ID is 1449. My topic is challenges in power management. Some challenges of power management are heavy apps using more power, high screen brightness, background processes, gaming, and graphics heavy tasks. Battery gaining, reducing performance. Next slide. Future trends in power management. Future power management will be smarter, AI-based power prediction to control apps intelligently, better battery technology, more energy efficient processor, improved cooling and thermal management. Next slide. Conclusion. To summarize, power management is a core part of modern operating system. It helps devices have power, run faster, stay cool, and last longer. Uh, with the rise of AI and newer hardware, power management will become even more efficient in the future. Thank you. That's all about our presentation.